Okay, so welcome ulit sa ating YouTube channel. Ito lesson 25 sa ating complex analysis, the upper bounds for moduli and of contour integral. So let's have theorem. So this is also known as the ML theorem, the maximum length theorem, or the modulus length theorem. So ito yung ML theorem, tandaan na. This is ML theorem. So this is LM theorem, which stands for modulus length theorem. Okay, so what is the modulus length theorem? So let curve C be a function from A to B going to a complex number with length L. Suppose that f is a piecewise continuous on Z. So if m is greater than or equal to 0 such that f of Z is less than or equal to m, then the modulus, so again modulus to, the modulus of the integral of f of Z dz along the curve C is equal to ml, where m is the modulus of f of Z. Okay, so again, yung modulus mismo ng f of z, and L is the arc length, meaning yung arc length. So sir, ibig sabihin kukunin namin yung arc length. So not necessary lagi mong kukunin yung arc length. Okay, so dito may mas madaling way para makuha yung arc length. Then note lang natin, lagi yung alalahanin to. So whenever meron kang nakita numerator, so sa numerator, kung meron kang modulus ng a plus b, by triangle inequality, this is less than or equal to absolute value of a plus absolute value of b. Then sa denominator, laging ganito, fix to, para dito sa topic na to. Denominator, we have the modulus. If we have the modulus of a plus b, this is simply greater than or equal sa modulus of a minus modulus of b, then modulus. So modulus of the difference of their modulus. Okay, so fix yan ang lagi gagamitin natin. Okay, so ito, magbibigay ako example para at least makita mo na. Pero hanapin muna ba namin yung arc length before namin hanapin. So may easiest way para mahanap yung arc length through drawing. So since parang circumference lang siya, so parang perimeter lang totally yung hinahanap pag arc length. Okay, so let's see be the arc of the circle from z is equal to 2, from z modulus is 2, then from 2 to 2i, show that the modulus of the integral of z plus 4 over z squared minus 1 dz is less than or equal to 6 over 7 pi. Sasama ko na yung z. Okay, so ito yung mga una mong ilahanin. Ito-drawing mo muna siya. Then sabi ko nga, since nakikita mo to, i-identify mo yung mga value. Okay, so note na yung f of z natin dyan is ito. Note na yung f of z natin. Note na yung f of z natin is z plus 4 over z squared minus 1. Okay, so start ko yung proof by ganito. So proof. So consider natin yung kanyang semicircular path o yung kanyang drawing. Okay, so sabi from 2 to 2i. So since nga 2 yung modulus, so this is 2, then ito yung 2i. So meaning yung drawing natin quarter circle lang, literal. So, yung integral dyan lang dadaan. Okay, ngayon, kung yung aking modulus o yung radius ko is 2, ano yung expected kong circumference niya? Ang circumference niya is 4 pi. Tama? Dapat that is 4 pi kasi that is 2 pi r. Tama? So, 2 times r, which is yung radius, that is 4 pi. Ngayon, since 4 pi siya, so expected ko na 4 pi. Ulitin ko lang ha. Yung area, by means of area pala, sorry. Yung area, expected ko, that is something na parang wait, isipin ko yung value. Tama nga. Tama yung isip ko. So, dito ko lang, yung circumference hindi area kasi arc length yung hinahanap. Yung circumference ng circle na may radius 2 is 4 pi. Okay, since quarter circle yung kinukuha natin, ano yung arc? Ano yung circumference na to? Kung yung 4 pi yung buo, ano to? This is pi. Okay, so again, yung arc length dito, yung L dito, is pi. Since the circumference is 4 pi. Yun tayo aware. Pero ito lang naman, dito lang naman dadaan yung integral, since that is only pi. So meron tayong L. Okay, so ganun siya ganun kabilis kunin. Ngayon, kunin na natin yung M. So note that M is equal to the modulus of f of z. where f of z is equal to z plus 4 over z squared minus 1. Okay? Then, by property ng modulus, this is modulus ng z plus 4 over modulus ng z squared minus 1. Then, apply natin to. Numerator is that absolute value ng a plus b. Then, denominator is modulus of a minus modulus of b. So, ito mangyari. This is modulus of z sa taas. This is modulus of z plus modulus of 4 all over modulus of z squared plus modulus of minus, that is minus modulus of negative 1. So again, negative 1 yan kasi a plus b tayo dun. Okay, so kaya negative 1 pa rin yan. Okay, note that this can be equal, so another, diba nangyari sa numerator lumaki siya, sa denominator lumiit. So kung lumaki yung denominator, lumaki yung numerator, lumiit yung denominator, therefore ito ay lumaki. Tama? So therefore ito ay lumaki. Kasi nga ito yung m natin eh. Okay? So next is, ano yung modulus of c? Modulus of c is 2. So papalit lang ko to. So this is equal sa 2 plus modulus of 4 is just 4 all over modulus of z squared. So note that yung modulus of z squared is pwedeng ganito. This is modulus of z raised sa 2 minus modulus of negative 1 is just 1. Okay, then palitan natin yan. This is equal lang sa 6 over, this is 2 raised sa 2. Okay, so I think that is 2 raised sa 2. Check lang sa given. Okay, tama, mali nga yung given ko. This is z cube. Okay, sorry papalit to, that's z cube. So pat yung ilalim, this is z cube minus 1. So this is z cube. Okay, so palitan ko lang yung mga given kasi nagkamali. Okay, so that is z cube. So this is 2 raised sa 3. Ito ko lang. So this is 2 raised sa 3 minus 1, which is, that is 7. 8 minus 1, that is 7. So that is simply equal sa 6 over 7. So lagay ko lang, yung f of z natin is less than or equal sa 6, 7. Ngayon, sabi ni Modulus theorem, kung meron kang f na piecewise continuous, so alam naman natin piecewise continuous yan, then yung m natin is greater than or equal to 0, which is ito. So greater than or equal to 0 siya. Okay, where f of z is less than or equal dyan. So yung modulus niya. Okay, then we have arc length, which is pi. Then by ML theorem, we have yung integral, modulus ng integral ng z plus 4 over z cube minus 1 dz is less than or equal sa m times l, where m is 6 over 7 multiplied by pi, which is equal sa 6 pi over 7. And this is done. So again, fix tong dalawang value na yan. Tapos yung pagkuha ng arc length, hindi mo na kailangan kunin yung length of arc using integral. Pero kung kinakailangan, gagawin natin. So number 2, suppose z of r is a semicircular path. Z is equal to r e raised to I theta from 0 to less than to pi. Find the maximum value of the curve. So pansinin mo na natin. So since hindi naman proving, hanapin lang natin maximum value na. So by ML theorem pa rin maximum value niya. Okay, so check natin. Una ako natin yung f of z o yung length, drawing muna natin by the way yung circle, I mean. So drawing natin yung circle. So since semicircular path siya from 0 to pi, so meaning dito siya. This is from 0, that is from 0 to pi, as with radius r. Okay, so kung radius r tayo, ano yung circumference niya? That is 2 pi r. Tama? So yung circumference niya 2 pi r. So ano yung length? Yung length dito is pi r. So yung length dito, that is pi r lang. So meron tayong length. So kunin natin yung modulus of f of z. So kunin natin yung modulus ng f of z, which is equal sa modulus ng z raised to 1/2 over z squared plus 1. Okay, note that ito pwedeng modulus ng sa taas. So this is just modulus ng z raised to 1 half all over modulus of z squared o ganyan minus 1. Okay, so ganyan lang, rekta na lang, okay lang. Next is, ano yung modulus natin ng z? Ang modulus ng z dito is r. Okay, so note that yung modulus of z natin is yung r. So meaning yung r, yung ito papalitan natin ng r. So this is simply equal sa, this is less than or equal sa r raised to 1 half all over r squared minus 1. Okay, then by ML theorem, so by ML theorem, so yung modulus na integral of z, integral ng z raised to 1 half ng z squared plus 1 dz along the curve c is less than or equal sa pi r neto. So this is pi r times r raised to 1 half, that is r raised to 3 over 2 all over r squared minus 1. So ito yung kanyang sagot. Okay, so ganun siya kasimple at kabilis. Okay, so for example number 3, so let's see denote the line segment from z is equal to I to z is equal to 1 by observing that all the points on the line segment, the midpoint is closest to the origin. Show that the modulus of integral of dz over to z raised to the 4th is less than or equal sa 4 square root of 2. So ganyan una, drawing nyo muna, ayun yung unang gagawin natin. So here's the proof. Okay, so una i-drawing ko siya. Siyempre, kung ito yung origin, so assuming ito yung I, kasi from I to Z, ito yung 1. Okay, so dahil line segment, drawing tayo ganyan, hindi circle. Okay, so sabi niya, yung midpoint daw niyan is ito. Yun yung pinaka-close along sa center natin. Okay, so yun yung midpoint. Ngayon, ang problema, kung ito ay 1, ito ay 1. So, tama, 1 unit, 1 unit. So, aware kayo na ito ay 90, dito ay 45, 45 na triangle, no? That is 45, 45 na triangle. 45, 45 siya na triangle. Yung total na arc length natin dito, ito ay square root of 2. So, in 45 degrees, right triangle. So, right triangle. Pero tayo na ganyan yung tsura nun. Ngayon, ano to? So, kung ito, square root of 2 over 2, diba? Ito ay 1. So, ano tong part na to? Ano tong gitna na to? Ano yung length nung nasa part na yan? So, ano yung length nung part na to? So, assuming zoom out ko siya, ganyan na magiging tsura. Nari, kinuha ko siya. Nari ganito. Okay, so kung ito 1 yung distance, tapos ito square root of 2 over square root of 2. So kung napansin mo, hinati ko siya dito, perfect na pagkakahati niya. So anong nangyari? So 'di ba, ito yung 90 degrees, magiging 45 to. 45 to, 45 to, ito yung 90. Tama? So ito yung magiging 90 degrees diyan. So square root of 2, square root of 2, ito is square root of 2 over 2. So ito is square root of 2 over 2 rin. So meaning yung gitna dito, yung distance niyan is square root of 2 over 2. So meaning yan yung parang radius na mangyayari. So yung modulus ng z natin dito, so wala to, disregard nyo yan. So yung modulus of z natin dito is somewhat greater than or equal sa square root of 2 over 2. So bakit ko sinabing greater than or equal? Kasi syempre, assuming na lumalaki yung value, so kunyari 2i 2, so pwedeng lumaki pa rin. Pero at least show tayo na square root of 2 over 2 siya. At least yung pinakamababang distance niya para dyan. Okay, so ayun distance ng z, nakuha ko na. So ngayon may arc length na rin tayo. Ano yung arc length natin? L natin is square root of 2. So bakit ko nasabi yung square root of 2 ulit? Since 90 degrees to, 45 yun, 45 yun. Since bakit 45? Kasi isosceles right triangle siya. So sa isosceles right triangle natin, sa isosceles right triangle, kung 1 to, yung opposite sa hypotenuse is square root of 2. Or a square root of 2. So 1 square root of 2, that is square root of 2. Then ang ginawa ko, hinati ko siya, zoom out ko. Kinuha ko tong part na to. Okay, so yung tinakpan ko, yung nakita nyo, yung hindi ka nakatakip, ayan yun. Okay, so hinati ko yung square root of 2, divide by 2, square root of 2. Since ito 1, nahati ko yun, naging 45 degrees yun, 45, ito is 90 degrees, kaya square root of 2 over square root of 2. So ayun yung distance niya. Okay, then we can proceed na dito. So kunin natin yung f of z, yung modulus ng f of z is just equal or less than equal sa modulus lang ng 1, kasi ganito lang siya, no? 1 over z to the fourth. Okay, which is equal sa 1 over, this is square root of 2 over 2 raised sa 4. Tama, ganyan na mangyari. Kasi yung z natin square root of 2 over 2. So this is less than. Kasi nagbago yan. This is equal. Sorry. Okay, then this is equal sa, this is 1 over 1 times 2 raised sa 4 tapos square root of 2 raised sa 4. Okay, so ilan yan? So magiging 2 raised sa 4, that is 16. So square root of 16, that is 4. 2 raised sa 4 is 16. So this is simply 16 over 4 or simply 4. So yung f of z natin is less than or equal to 4. Okay, so by ML theorem, so we have yung modulus na integral ng dz over z to the fourth, z raised to the fourth along the contour z is less than or equal sa square root of 2 times 4, which is equal sa 4 square root of 2, and that is done. Okay, so ganun din by analyzation. So set mo, consider mo bang radius yan? Yes, kunyari pumarm ako ng circle, radius na siya. So kaya nga greater than or equal to square root of 2. Possible kasi na yun yung pinaka possible na maliit. So baka mas malaki. Kasi nga kung ipo-form ko ng circle, iba na itsura. Okay, so kaya kinonsider ko rin para siyang radius. Okay, so next is we have the Kushi-Gorsat theorem. So itong Kushi-Gorsat theorem, I think somewhere gagawin ko to na example, pero for the meantime hindi muna kasi unahin ko muna si Kushi integral formula. So for the meantime ipoprove ko muna si Kushi-Gorsat theorem. So ipa-function f is analytic at all points, so meaning differentiable siya at all points. So 2 in a simple closed curve C. So closed curve, literal. Okay, then the integral of f of z dz along z is equal to 0. So, ito ko lang, kaya nga ito yung gagawin natin eh. Kaya nga ito yung gagawin ko. Hanap ako ng example ng Kushi-Gorsat theorem. So, at least ma-verify natin bakit ba siya simple closed curve, tapos bakit interior at all points, so differentiable at all points. At least may ipapakita ko sa inyo okay, paano ba application ni Kushi-Gorsat theorem. So, by the meantime, ipoprove muna natin siya. So, I think gagamit ako dito ng Green's theorem. So, para mapatunayan natin na equivalent. So, gagamit ako ng Green's theorem sa kanong Kushi-Riemann relation o yung Kushi-Riemann equation kung naalala nyo yun. Okay, so let's have the proof. Ito yung proof niya. Okay, so recall ko lang. Recall that integral of f of z dz. So, recall na yung integral f of z dz can be written as integral along z ng u dx minus b dy. Okay, then plus I integral ng u dy plus b dx. Okay, where since, bakit yun? Since yung f of z natin is equal to u plus ib, tas yung dz natin is equal to dx plus I dy. So kung naalala nyo, ginawa ko yan. Okay, so ayun yung gamit yan. So another recall is what is the Green's theorem. So by Green's theorem, i-apply ko yung Green's theorem both dun sa dalawang sa taas na yun. So by Green's theorem, that is partial, that is u dx minus b dy, that is partial of b. So ang mangyari doon is simply ano ba yung Green's theorem by the way? Ang Green's theorem natin, pagkakaalala ko is ganito. Integral along r ng p dx plus q dy is equal to the double integral along the surface A nung partial of q. So kung naalala ko yun, no, partial of q, so this is partial of q with respect sa x minus partial of p with respect sa y, then dA. Alam ko ganun yung mangyayari. Okay, so apply natin dito sa part na yan. So this is u dx, so magiging partial, negative partial of b, no, with respect sa x. Ganun yung mangyayari sa kanya. Kasi q dy eh. So negative yun. So this is equal sa double integral along c pa rin. So kasi complex plane naman tayo ng negative b, so negative b tayo dito. So negative b partial of with negative partial of b with respect sa x, then plus or minus u dx yun, so that is p with respect sa y, then dA, then plus I double integral along the curve C or the complex plane ng part na to. This is b partial of b with respect sa y, tama kasi parehas pa rin naman. Ito pala u, partial of u with respect sa y, then partial of b with respect sa x. Ganun yung mangyari. So this is partial of u, arrange ko lang. Ang gagawin ko is partial of b, dito kasi galing. Ito kasi may y eh. Okay, so ito yung mangyari. Ito yung unahin ko. So partial of u with respect sa x. Tama? So partial of u with respect sa x. Tapos ito yung may b dx. So that is minus partial of b with respect sa y. So minus partial of b with respect sa y. Then dA. So arrange kasi ito. So ito kasi pag pinorm, ganito kasi siya, or ay integral ng b dx plus u dy. So para ma-form tayo sa Green's theorem na yan. Okay, kasi p dx plus q dy. That is b dx plus u dy. Kaya ganyan itsura. Okay, next is by Kushi-Riemann equation. Recall that by Kushi-Riemann relation, since analytic yung f natin, so analytic at all points, so meaning differentiable siya at all points, so applicable si Kushi-Riemann equation kasi differentiable siya. Aware tayo na yung partial of u with respect sa x ay equal sa partial of b with respect sa y. And yung negative partial of b with respect sa x ay equal sa partial of u with respect sa y. Yan yung sa Kushi-Riemann equation. Kung naalala niya, assumption yan ng Kushi-Riemann equation. So, applying yan dyan. So, sabi, yung u is b raised to y, tapos yung negative bx is uy. Okay, kasi, ba't ko ginawa p to? Dito p, by the way, this is u, sorry. U. So, mangyari, this is equal sa integral, double integral, along c. Yung negative bx natin is uy, partial of uy, then minus partial of uy dA, plus I, double integral of c, then yung u of x natin is by minus by, then dA. Okay, note that ito is 0. Integral ng 0 dA is 0. Integral ng I 0 dA is 0. So this is just equal sa 0 plus I 0, which is equal sa 0. So therefore, yung integral ng f of z dz along the curve C is equal to 0, and that is done. Therefore, the Cauchy-Gorset theorem is proven. Okay, so ayan, this is all about yung topic natin, maximum modulus theorem, saka yung ating Cauchy-Gorset theorem. Si Cauchy-Gorset theorem, hahanapan ko lang siya na application kasi mahirap din talaga siya hanapan na application kasi theorem lang talaga siya. So once sinabi lang na analytic siya, tapos simple and closed curve, automatic lang yung integral nun is 0 by Cauchy-Gorset theorem. Okay, so ito pa yung kailangan natin malaman. Kailan siya magiging analytic? So alam natin yun, dapat differentiable siya. Kailan naman magiging simple closed curve? So, yun din dapat natin alamin pa. Okay, so thank you for watching. So, hoping na panoorin mo pa yung next video dito.